What a DFT software package does is mainly to solve the quantum equation. In the quantum equation, the first term of the Hamiltonian is the electron's kinetic energy. The second term is the interaction between the electron and the nuclei. The third term is describing the interaction among electrons. And the fourth term is the exchange correlation potential. The third and the fourth terms are the functional of the electron density. So in order to set up the quantum equation, we need to have knowledge of the system's electron density as the input. But the electron density is equal to the sum of the squared wave functions for all occupied energy states, which are only known when the quantum equation is solved. This means the input electron density is dependent on the output wave functions. So we will have to solve the quantum equation iteratively with the self-consistent field method. The overall workflow of the self-consistent field method is like this. First, we give an initial guess for the electron density. Since a material is composed of atoms, it's reasonable to approximate the system's electron density as the superposition of the electron densities of constituent atoms. Then we can calculate the potentials that depend on electron density. With these terms computed, we can set up and solve the quantum equation to get the wave functions. Summing over all the occupied energy states gives us a new electron density. Then we can compare the input and output electron density. If they are not very close to each other, we see the convergence is not reached. We feed the output electron density back to the beginning of the SCF loop. When the convergence is reached after many iterations, we can use the converged electron density to compute interesting physical quantities such as force, stress, band structure, and density of states.